Hi, I am Sendil Armugam. As part of the Machine Learning Software Foundations program by Data Sciences Institute of the University of Toronto, I worked with ML Group 8 on the team project. Our project focused on predicting stock index trends using machine learning on NYSE data, with the goal of applying ML techniques to a realistic financial forecasting problem. This project gave me the opportunity to apply machine learning concepts in a real-world workflow and gain insights into financial forecasting. I started the workflow by engineering features like relative strength index and winsorized extreme values. I built models from two different families, CNNs for sequence pattern recognition and LightGBM for nonlinear tabular data. This gave me practical experience in understanding how different model types respond to low signal-to-noise financial datasets. To ensure robust evaluation, I implemented a time series split, which prevented data leakage. I experimented with sliding windows to create overlapping sequences for CNN training and improve pattern recognition. I optimized models using cross-validation, trained them with the best hyperparameters, and conducted feature importance analysis to interpret which indicators contributed most to predictions. These are the parameters of the models. And these are the performance metrics of these models. One major learning was how to translate a business problem into a structured ML solution, defining objectives, scoping the analysis, and selecting models suitable for time-dependent financial data. I also learned the importance of feature engineering to improve signal quality and allow the models to detect patterns that raw price data alone could not reveal. I understood why accuracy in financial markets behave differently from typical ML tasks. Stock prices are stochastic and influenced by macro news and investor sentiment. One specific issue we encountered was that the dataset had slightly more upward movements than downward ones, which caused the model to predominantly predict a bullish market. These issues gave me practical exposure to problems like majority class learning and the limitations of accuracy as a metric in finance. Financial data must remain strictly time-ordered to avoid look-ahead bias. Hence, test-train split must be done with due consideration. Datasets and models like these require extensive resource use for data pre-processing and model training. I experimented with technical indicators such as RSI and applied winsorization to reduce the impact of extreme values, generating smoother, more meaningful features. I also implemented a time series split to maintain chronological integrity and avoid look-ahead bias, ensuring that evaluation reflected real-world performance. I optimized computations by monitoring algorithmic efficiency, which allowed experiments to run effectively without overloading resources. For project management, we used GitHub project and had Scrum-style daily stand-ups. With more time, I would integrate real-time or streaming data, implement transformer-based architectures to improve prediction reliability, build a lightweight web dashboard using Streamlit. These enhancements would push the project closer to something deployable for analysts or traders. On the technical side, I bring skills in time series analysis, feature engineering, model experimentation, particularly in scenarios where the data is noisy or unpredictable. On the project management front, key strengths I bring to the table include planning, structure, and clear communication. I enjoy creating order from complexity and helping the team stay aligned. I also value collaboration, making sure knowledge is shared openly so the entire team can understand the reasoning behind models, features, and decisions. Overall, this experience strengthened both my technical and collaborative skills, and it helped me develop a project I am proud to showcase as part of my portfolio. I would like to thank my teammates and the DSI instructors for sharing their knowledge.